Hello, everyone. In this lecture, we're going to talk about the analytical methodology. So this is the outline of this lecture. We are going to describe the analytical methodology, but in a very high level, and how to implement data analytics to achieve successes in business. We're going to describe each steps in the analytics, in the analytic flow with examples. Okay. So through this lecture, I want to give you guys a bigger picture about how analytics is done. And as you can see from this slide, data mining is not a linear process. It is a cycle where later results can lead back to previous steps. Some people may think data analytics is you get the data and clean the data and then analyze the data and got the results. That's it, right? But as you can see from this picture, in order to do a better analytics, first we need to define and refine the objective. Okay, very specifically, what is your objective in the analytics? And then we can go ahead and select data. As you can see, this is not a linear process. We can see arrows going back and forward. So after you select data, you explore the input data and then prepare and repair the data, because the data, sometimes people may complain the data is not clean and the data has some issues and they cannot be readily used for the analytic model. So that's why we need to prepare, pre-process, and repair the data. What do we mean by repair? Because, for example, you might have missing data, not applicable or not available. And then how do we deal with the missing data issue? So there are many methods that can be used in the analytics methodology. So the next step is you want to transform the input data, because sometimes input data may not show you the useful information or the information you need directly. You may need to visualize them, transform them, and maybe transform them in a different to a different domain, for example, time domain. And you want to analyze how frequently people make the purchase. Maybe you can check the frequency domain, right? And then you can apply the analysis, build the model. When you build the model, you may find, oh, the data may not be what you need. You see here, you can go back to select the data again. And after you apply the analysis and evaluate and validate your model, now it's time to deploy your model in the real world practice. And then you keep assessing your results. You see, when you assess your results, it's not as good as it looks like, or as in the training process. You may go back and reapply your analysis, maybe adjust your model. And as you can see, we see many curves backward, right? We see many curves, they can go backward. So those steps, they are not a sequential process or sequential linear process, but rather they are interactive or intertwined process, and we want to make sure revisit the previous steps, make sure every step is done correctly, so that we can have the best model to achieve our business objective. So in this lecture, we are going to focus on the first block, how to define and refine the business objectives. Why have a methodology? So we have this methodology, this flow chart. Why do we want to follow this methodology? It's because we want to avoid learning things that are not true, avoid learning things that are not useful. For example, the results that arise from past marketing decisions, results you already know, results you already should know, or results you are not allowed to use. And also, we want to create very stable models. So that's why we keep revisiting previous steps, and then we keep fine-tune our models. Or we want to avoid making the mistakes you made in the past. So that's why we go back to the previous steps and to develop useful tips from what you learned. Okay, now let's focus on the step 1, define business objectives and state it as a data mining task. So define the business objective, as we can see from this slide, there are several examples. And the business objective could be improve the response rate for a direct marketing campaign. And you can send advertisement through TV. You can advertise through different ways, right? TV, radio shows, or the mail through mails, right? Newsletters. So different kind of response rate. And we want to increase the average order size. So profile your customers. Determine what drives the customer acquisition, how to increase the number of customers. Forecast the size of the customer base in the future. Choose the right message for the right group of customers. And target a marketing campaign to maximize incremental value. Recommend the next best product for existing customers. Yeah, recommender system is a very classical system of data analytics. If you go Amazon, when you go shopping, you see people also buy some other stuff, right? So those are the recommending system for you when you buy it again. And they are relevant product, cross-sell product. When you buy something and there's some cross-sell opportunities, and so that those retailers and like our e-commerce website, they can maximize their revenues and by study you as the customer. And we can segment the customers by behaviors. For example, Netflix, they do a lot of clustering of their customers. Some customers, they like cartoon movies, like the kids, right? Other customers, they like action movies or adventure movies. Yeah. So we want to segment those customer behaviors so that we can recommend the relevant product to the customer. Sometimes we can recommend some new movies for them to buy or rent. So in order to define the business objective, I think we need some domain knowledge. That means if you study a particular area with a particular group of set of data, you want to understand the domain knowledge of a particular area, a particular subject. For example, the marketing campaign. You got to understand how to do the marketing. What are the possible ways and what kind of data are available so that you can refine your business objective. A lot of good statistic analysis is directed at solving the wrong business problem. They may have very nice or very good analytic skills. Okay, they have very handy statistic tools, but they are solving the wrong problems. So any analytics project, the first step is to define your objective. Make sure you have the right business problems to solve. Now let's have a look at an example, how to define the business goals. For example, people love yogurt. And so you wanna know who is the yogurt lover in the customer database, right? And but in order to know who, you got to define what is a yogurt lover, right? Who love yogurt? So those kind of if you can answer those questions, you can print coupons, right, at a cash register to encourage their purchase of yogurt, or you can mail coupons to people's homes. And maybe you have a different advertising strategy, but the first question to solve is who is the yogurt lover in the database, and how do you define the yogurt lover? Now, it comes to the definition of a yogurt lover. So yogurt lover, you cannot, there's not a label in the database label of people called yogurt lover, right? So it's not in the data, but you can predict or you can impute it using the business rules. For example, anybody who loves yogurt, they tend to spend a lot of money on yogurt. And they also spend a relatively large amount of their shopping dollars on yogurt. So if you plot your customer spendings in this way with a histogram, right? The x-axis is yogurt as percentage of all purchase. If this is high, right? So in this axis, if this is high, right? In this way. So if this is high, then this person could potentially be a yogurt lover. But also you want to see what is the percentage, not only the percentage of all purchase, but also you want to see the dollar amount spent on yogurt. Okay, if this is also high, then this yogurt lover actually in this area. Okay, so obviously this customer segment is the segment you wanna target as yogurt lovers, and definitely if you have more budget, you can also target those areas, right? For example, you focus on this area, this block, but randomly you allocate some budget in these 3 areas to increase more people, right? To increase more people as yogurt lovers, so that you can get more revenues. So if you based on these 2 attributes, you can find the people who are yogurt lovers, but you want to profile them. Profile means you identify the segment of customers you believe are yogurt lovers, but who are they, right? Who are they? You gotta identify their mailing address. So that means you gotta go to the database, identify their mailing address as well. And how would I know them in the store? So demographic data you need. Now, once you identify the yogurt lovers, you wanna associate the yogurt lover and then identify the demographic information, and maybe identify by other things they purchase. For example, those people who love yogurt tend to buy nutrition bars or sports drinks, and maybe some healthy food, other healthy food. So what action can you take? So first, you define the yogurt lover. Second, you profile them. Third, what actions can you take? You may set up yogurt lover attracting displays, right? So now it's time for you guys to think about if a customer is identified as a yogurt lover, what action should you take? Should you give them yogurt coupons, even though those individuals buy yogurt anyway? Maybe there's a new brand of yogurt. You want them to try, maybe they love it and they will buy more, right? Is there a cross-sell opportunity? Yeah, there may be a cross-sell opportunity. When people come to buy yogurt, you can place something else related to yogurt on the side. And so there are some cross-sell opportunities. This is relevant to the shop floor design. And is there opportunity to identify potential yogurt lovers? What should you do? So those are all the questions and you can do and you can solve with the data analytics. Now, profiling in the extreme. This is a successful example from Best Buy. So Best Buy actually used analytical methodology very early, okay? They discovered a small percentage of customers accounted for a large percentage of revenue. Over the past few years, the company adopted a customer-centric approach to store design and flow, staffing, and even corporate acquisition, such as the Gig Squad support team. The company's largest competitor has gone bankrupt, while Best Buy has seen growth in the market shares. So this is the power of analytics. If you recall their competitors, there is there was a large electronics retailer called Computer USA. They actually sell similar things as Best Buy, but they went bankrupt. So this tells us, I mean, in nowadays, if we don't do analytics, if we don't study our customers, and yeah, it's very hard to survive for those retailers and in this competitive market. So now let's see maybe another example of the business objective. I give more examples because this is a very important first step in analytics, because we want to define our objective before we do anything. And so what is a business objective? For example, telecompany, they have churn. Churn means you switch from AT&T to Verizon. This is called a churn. And the problem is you want to assign a churn score to all customers. So you have all the customers. You want to see who is more likely to churn. Maybe recent customers with little call history, and telephones, individuals or families. And are they playing a role? Are they playing a role of voluntary churn versus involuntary churn? Okay. And if you assign a score to all the customers, and how can you use them, right? Then you can develop a customer retention program. And maybe a better objective is by September 24th. And through the analytics, you provide a list of 10,000 elite customers who are most likely to churn in October. So provide this list, and then we can have strategies to retain them, or have a retention program, and to give them some discount, let them remain in the program. Now, this objective is very actionable, right? Now, credit card, people also churn in credit card. And how do you define your target? Churn or not? You may have a classification model to see whether a guy who's going to churn or not. And when did a customer leave? So when she has not made a new charge in 6 months, the credit card has no new charge. When she had a zero balance for 3 months, when the balance does not support the cost of carrying the customer, when she cancels her card, when the contracts end. And some people, they may use the call center data. I mean, call center data, people call to churn. That means they are going to churn, right? They just inform the credit card company that they are going to cancel their card. And so this is not a very useful data set, because people has already card, then you can predict 100% they are going to churn or they're going to cancel their card. And in some other scenarios, people's card inactive for a long time, then they automatically get canceled. That's because the credit card company is studying your behavior. Because if you haven't used a credit card for a long time from Chase, maybe Chase just cancel your card. And so that's why people are studying, those companies, they are studying their customers. There's another interesting phenomena from the credit card company that's called anniversary churn. You see the people churn, originally it's very small percentage, maybe less than 0.1%. But suddenly in the months, as you can see from x-axis, this says tenure of the month. In the month 12, suddenly you have a huge high spike of the people who churn, right? It goes to 1%, and maybe goes up to the 3%. So it's actually out of the boundary. So it goes this way up to 3%, all the way to 3%. So this is called anniversary churn. Can you guys think why people cancel after 12 months, or they churn after 12 months? Okay, this is because many people, they have 0% APR for 12 months. Then after 12 months, they don't use that card anymore. So and maybe there any other anniversary discount other programs they are in. So after the program ends, they just cancel their card. So this is called anniversary churn. Now, next, if you define your objective, we still need to translate the objective into the data mining tasks. Do you already know the answer? How to translate objective into data mining tasks? We discussed this a little bit because in supervised data mining, the data has examples of what you are looking for, such as the following: customers who responded in the past, customer who stopped, transaction identified as fraud. So those can be used as classification or regression models. You can predict and who stopped based on whatever factor, and you can classify who churn, who 0 and 1, who will churn, who will not, right? But in supervised learning, you have outcome and target defined. In the unsupervised learning, you don't have a target variable or response variable. You are looking for new patterns just in all the predictors. So this is a Y. And here you have all the X. And in X, you want to find the new patterns, associations, and ideas. Okay, so those are the clustering problems. Previous one are regression and classification problem. Now, data mining tasks leads to specific techniques. The objectives, so first define your objective: customer acquisition, credit risk, pricing, customer churn, fraud detection, discovery, or customer value, or segment your customer behavior, right? So those are the objectives. Based on the objectives, you have tasks. Tasks can be exploratory data analysis, binary response modeling, this is classification, multiple response modeling, and you have multiple class classification. You have estimation problems, and forecasting, anomaly detection, and pattern detection. So those are the tasks. And those tasks are corresponding to different techniques. So here I put the IFM. What is IFM? IFM means recency, frequency, and monitoring. So if you want to find potential good customers, you have 3 dimensions. You have recency dimension. Okay. If you put all the data into the box, you will have recency and the frequency, and then you have monitoring. So this is called histogram, 3-dimensional histogram. This is exploratory data analysis, and it's a very useful technique and widely used for by many companies. Recency means how recent your customer makes the purchase. For example, you are the customer. How recent you make the purchase, and how frequently you make the purchase, and how much money did you spend. So you see, if you are the customer, if you spend recently and you spend more frequently and you spend a larger amount of money, definitely you are a very profitable customer. So we want to identify those customers so that you can do the customer acquisition. So the techniques, so IFM, recency, frequency, and monetary analysis is one way to do it. Now, techniques also include decision trees, regression, neural network, survival analysis, clustering, association rules, link analysis, hypothesis testing, visualization. I understand this is undergraduate level class of engineering analytics, but I want to present a big picture of those techniques, and so that you know they exist, and later you can pursue those techniques, okay? And it requires more mathematics and statistics foundation to pursue those. Especially, we need to complete the class of IE23, statistic methods in IE, so that we can go forward to learn more data science techniques. But here, in this lecture, I want to give you a bigger picture. So what are the steps? What is the flow of analytics? I'm not going to dive into details on how to build a decision tree, those kind of things. But I want I want you guys to understand the existence of those methods in the first place, and so that you know where to go and where to what to pursue, right, in the future, if you want to pursue an business analytic career in the future. So data analysis is pattern detection. Patterns may not always represent any underlying rule. Some patterns reflect some underlying reality. So the party that holds the White House tends to lose seats in Congress during off-year election. So this is they are related, right? But others don't. So, for example, when the American League wins the World Series in Major League Baseball, Republicans take the White House. Okay, so this is, I mean, even if they correlate, right? But they are not necessarily means correlation does not necessarily mean causality. Okay. Sometimes it's also difficult to tell without analysis. For example, in U.S. presidential contests, the taller candidate usually wins. And if you look at the data from the past 50 years or 60 years, you see maybe more than 60% of the taller candidate they wins, right? So it's hard to tell whether it's true or not, but without the analysis. Now let me give you another example on how to properly define the objective and then translate it into the data mining tasks. So this is an example from KDD Cup, a data mining competition associated with the KDD conference. You can visit the KDD conference. This is for a data mining conference. The purpose is to maximizing profit for a charity fundraising campaign. Test on actual results from mining using the data withheld from competitors. So the objective is to, I used to participate in the fundraising campaign. I write letters, and I write a lot of letters through the network. And we have a group of people sitting in the room, conference room, and we started to write letters and then putting them in the envelope and then send it out. Try to maximize ask people to donate. But the question is, to whom you should send the letter and to whom you should solicit the donation, right? So competitors so in this competition, they actually took multiple approaches. They use all kinds of approach to do the modeling. Some of them, they model who respond. Some of them, others, they may model how much people give. And perhaps they have more esoteric approaches. However, the top three winners all took the same approach. Although they use different techniques, methods, and software, but their approach is the same. What is the approach? The winning approach is they are modeling the expected revenue. So the first task, they want to identify the potential donors. Okay, they have a potential donors, all the people in the database. Now the first task is to estimate the response, the probability that a person respond to the mailing. From all the customers, you identify the probability who will respond. And then you estimate the value of response. That means the dollars. For those people who respond, how much they are going to give. And then you are going to choose prospects with the highest expected value. That means the probability to respond times the dollar they are going to times. So here, this is expected, highest expected value. So this is a two-stage approach. First, you identify the people. Second, you identify the money. Then you use the response variable, response, probability to respond, multiplied by the dollars they're going to give. And then the people who with the higher expected values, you just send the mails to them to solicit the donation. So this is a winning approach. It takes two stages. Now there's an unexpected pattern. Okay, when people give money more frequently, they tend to donate less money each time. You know, in most business applications, as people take an action more often, they spend more money. But donors to a charity are different. This suggests that potential donors go through a two-step process. Shall I respond? Or how much should I give? So this is exactly the two-step or two-stage modeling approach that all these three winning approach, top three, they have taken. So that's why modeling follows the same logic. Again, I want to emphasize the domain knowledge, and you want to understand the problem, understand the business problem first, okay? Okay, now we finished the first step, define and refine business objectives, and we use multiple examples. And in the next video, we are going to talk about how to select data, explore input data. So this is the end of this video.